Okay, good morning class. So today we're looking at analytical geometry. We're looking at the examples for exercise 4.4. Examples for exercise 4.4. Exercise 4.4 is on page. Is that it? 94. And these examples is on page. Sorry, example 1. Page 93. Right. Right, so here we are told, let me just cut this. Here we are told that we got more complex examples dealing with angle of inclination, okay? So in our last lesson we looked at angle of inclination. Now we're going to look at more complex examples dealing with that. So here we are told straight line y is equal to 2x, y is equal to 2x, which is this one here. Y is equal to 2x, which is going through the origin, of course. And y is equal to negative 3x plus 6. Y is equal to negative 3x plus 6, which is the decreasing straight line function, real linear function. Intersect at A. Then we are told that a beta and theta are inclination angles of these two straight lines respectively. So in that order, so for 2x you got beta, and for y is equal to negative 3x plus 6 is your theta angle. Refer to the given diagram and calculate the values of the following corrected two decimal places. So when we start with beta here. So what do we know? We know that we have to work out this angle. How do we work out the angle, people? We use tan of beta is equal to the gradient. Not so. So what's the gradient of this line here? 2. So tan of beta is equal to 2. So how do I get beta on its own? Arctan. Put on the calculator, shift tan or arctan of 2. Give me an answer of 63,43. Okay. So normally if I have a diagram, what I do is I fill this information in on the diagram. So that's 63,43. How do I work out theta? How do I work out theta? In B they ask you to work out theta. So I take tan of theta is equal to the gradient of this line. Is that line in standard form of y is equal to mx plus c? Yes. Yes. What's the gradient of this line? Negative 3. So y is equal to negative 3. So this angle is going to be negative, not so? Yes. So what do I do? I'll add 180. Because this theta angle is obtuse. Okay. So arctan of negative 3, or shift tan, second function tan. Arctan of negative 3. Give you 71,56. Negative 71,56. And the number gets 1 plus 180. With theta angle of 108, okay. And then thirdly, they ask you to calculate angle A1. So what do we know? That exterior angle is equal to the sum of the two interior opposites. You got that? Or you can work out angles on the straight line and go sum of triangles. Okay, so of course the exterior angle, so is 108,43 is equal to A1, angle A1 plus 63,43. Do I need a reason yet? No. It's only in Euclidean geometry or where they ask you to give a reason. Okay, you give a reason. Otherwise, therefore, angle A1 is equal to 108,43 minus 63,43. Give an answer of minus 63,43 gives you an angle of 45 degrees. Is there any confusion here? Okay, so that's pretty simple. That's the only example dealing with this exercise. Okay, so what I did was I took number 4 out of exercise 4.4. So this is number 4 from this exercise. Okay, so now I like to say it's from this exercise. Okay, you are given a diagram as well. Questions. So the question says, okay, we need that there. We need that. It's a bit too big. Alright, so what we have here, people, is lines y is equal to negative x plus 1, which is this line here. And y is equal to x minus 1, which is this line going through there. Both intersect the x-axis at point S. The angle beta and alpha are inclination angles of those lines respectively, which means to say in that order. What's the question? I didn't cut the question. What does the first question say? Calculate beta. Calculate the size of angle beta. Okay. So beta, what does question B say? Calculate alpha. And then C is TSQ. Not so. So that angle TSQ that you came on, so let's go with A. Oops. A. So if you're looking at angle beta, what do I need? I need to know the gradient of this line. What's the gradient of TS? Negative 1. So tan of angle beta is equal to negative 1. So what do we now say? For beta is equal to arctan of negative 1. You only agree there's going to be a negative value. Then what do? Add 180. So shift tan of negative 1 gives you negative 45. So it's a negative 45 plus 180, which gives you an angle of 135. Okay, there's 135 there. Then they want you to work out angle alpha. Okay, so what do I need for alpha? I need the gradient of QS. Not so. What is the gradient of QS? The tan of alpha is equal to, the gradient of course is 1. So alpha is equal to arctan of 1, which is 45. There's also a special triangle here. Not so, special angle there. So that is going to give you 45. Then the question is to calculate TSQ. So if you're looking at TSQ, so this angle here, you all agree with that? So what happens is, you got this angle beta, you got this angle alpha. So TSQ is actually, TSQ is going to be beta minus alpha, not so? So TSQ is equal to the beta angle minus alpha, which is 135 minus 45, which is also equal to 90 degrees. You see that, people? How else could we have known this is 90? If you say, what is this gradient? Negative 1. What is this gradient? 1. If you multiply, you see, negative 1 times 1 will give you negative 1, not so. So what happens if you multiply two gradients and the answer is negative 1? It's perpendicular, so it's 90 there. Everybody guys understand? Any confusion? For those of you who did this exercise, was there any problems with the homework? Wasn't supposed. Right, now you got to do it. For homework, I would like you guys to do exercise 4.4. Okay.